Hello and welcome to part 2 of 3 episodes on how to use a DC motor with Arduino. In this one we are going to be controlling the speed of the motor using the transistor. So let's start off with some fixes that need to be made at the end of the last episode, as mine actual real life version didn't work. So the motor didn't spin, the transistor kept heating up, but by adding a 2 kilo ohm resistor it actually fixed it. It stopped heating up, the motor span barely, but it still spun, and it just altogether seemed to work a little bit better. So the resistor that I changed was the one that is connected to the transistor here, so that is the 2 kilo ohm resistor. It is actually shown with the picture in the top left right about here. So yeah, I also have an image of the transistor and the motor. If you can't tell, I'm actually recording this audio post video due to the fact that my audio corrupted itself and didn't record my mic, so if things are a bit out of time, that is why, but it was recorded and I'm trying to go along with it as best as I can. Just a bit there. So the new code, there is actually nothing new with the actual system, nothing has changed with the system, it's the same thing, one motor, one transistor, one diode, LED resistor and a 2 kilo ohm resistor instead of 220 there. That is the only difference there, that is it, nothing else changes. So don't change anything except the 2 kilo ohm. But yeah, that is it. So the new functions that are actually in the code are the while not serial loop, an if loop, an analog write, and a serial pass integer. So the while not serial means that while the serial is not open, it will not actually do anything. It will halt every bit of code that is actually on the breadboard. The if loop will run if something is happening, so if something's happening, the if loop will run. The analog write is used for pulse width modulation. That is where you are writing using pulse width modulation, so that is how the speed is controlled. The speed is controlled with pulse width modulation. And serial.pass integer, I can't exactly remember. I can try and find out, and I'll put a little comment in the description that says what serial pass integer is. That'll be in the comment section below, so just make sure you look there, or you can search up on Google yourself. They are your options. So let's get on to actually making the code for this one, shall we? Alright, so here is the circuit. This is the same circuit that has been used for the last episode. Nothing changes, everything's the same, although I am going to change this resistance to 2 kilo ohms. As you can see there, that is what is the resistor, so that is the resistance that is used. Don't worry about it. So as you can see, when we start the simulation, everything still turns on, everything's fine. However, now we want to change the actual code. So there's a little bit that needs to be added to the void setup. We need another pin mode. This is for our motor pin, so because we're changing the speed, we actually need the actual pin mode set. So this is output, because obviously you're not going to input something with a motor, because that just wouldn't make sense. We then want to put in our while not serial loop, not serial command. However, what I did end up figuring out is that we do actually want that before the serial.begin. So I'm going to just copy that, and I'll just paste it in the top. So just highlight, there we go, copy, cut, and paste it above it. There we go, because now the serial begins before the while not serial has happened. And we write the final thing of serial dot print ln. So here we're printing the number of speed 0 to 255. So what happens is you'll put in, so what happens when you actually run the code is, using your serial monitor, you put in the code, a number from 0 to 255, and that will define what speed it goes at. So let's set that up in the void loop. So in the void loop, we want to get rid of our motor pin high. We don't want that. That is not needed for this one because it's going to move depending on the speed. So we now want a for loop, I think. If loop, not for loop. That's for the next episode. An if loop. So if the serial dot is available, so if the serial is available, then so the if loops always end with a little curly bracket. Always end with that. So then we have another integer that we are defining in this if loop, so in the integer of speed, which equals the serial dot pass integer. So that is where the pass integer comes in. I really don't know why it's pass integer, but I will find out. Put in the comments. So that is the integer of speed, so speed equals pass integer serial dot. So if speed is greater than or equal to 0 is what that is meant to be, and speed is less than or equal to 255. As you see there, I complemented where the equals should be there. There it is. It's my equals. And speed is less than or equal to 255, then analog write. So this is where we are using our pulse width modulation. Analog write motor pin to speed. So whatever the speed number that was put in, so whether it's 0 or 255, 150, anything like that, it will set that analog write to the motor pin. So you see here, this is the node, so it creates a PWM wavelength. So this is the wave of the PWM, so this will move depending on the speed, and it will change depending on what speed you put in. So that it will run if the serial is available. That's what this... So when you open your serial monitor, that means the serial is available. It will not run the code unless that is done. So just add... So these are all of the little add-ins that you can add if you really want to. They aren't necessary. Anything that's after the slashes aren't necessary, but they do help know what is actually going on. So it can be quite useful if you're using this for, say, a task or something like that. You can use that to do that. So you can describe what is happening there, and it will work just like that. Oop, that was a mistake. There we go. Right, so that is the code, so let's just hide the code, I guess. Not really and truly, I should hide the code because I'm not going to start it while it's open. So, as you can see, well, actually I do need my code open because I need to access the serial monitor, although I closed it. So we're going to start simulation, and as you can see, there's an error. Great. So what I missed here was there are two little curly brackets here, so for both of my if statements I needed to close those and I didn't, so you need to make sure you always close if, while, when, well, it's not a when one, but if, while, for, all of those kind of loops that end up being purple. Always make sure you close them, because otherwise you'll get an error, and it could show up the error as something really obscure, but it could just be missing something like a semicolon or something like that. So here you can see that I've got the actual IDE up here. It's not very useful, so there's the void loop, so void loop, and there we have our brackets. So always, so on the actual IDE it will show up what bracket it is that's actually being closed, and it should automatically add that bracket in, so you don't need to worry about it. If it doesn't, just make sure you always check, and if you when you upload it, you can verify it and then upload it. Make sure you save it so that you actually have it saved in case it corrupts and crashes, because you don't want that to happen. So once that's done, it's all good, everything's fine. You press the arrow, upload it, but you need to make sure before you upload that you have got the port selected that your Arduino is plugged into. Don't carry I have one plugged in, so it doesn't show up there, but it will show up as Arduino Uno port, say COM3 or something like that. So always make sure that you plug those in. But anyway, that should be the fix for that. So let's start the simulation, and as you'll see, it is currently going 0 RPM, 0 revs per minute. It's just not moving at all. There is nothing moving there. However, when we open up our code and we go onto the serial monitor, if we put in, say, I don't know, 115, 255, let's go with 255. Yeah. So as you can see here, this is going the max speed, which is about, what is that, 1900 RPM. So that is the max speed that it can actually go. If you put it lower, it goes down a lower speed. If you put it even lower, again it goes lower. So it can just keep going lower. If you put it to 1, it's barely going to spin. However, with the DC motors, they will not actually spin at anything lower than 50. So always make sure you do actually have it set to minimum of 50 to 255. If it's lower than 50, it will not spin, and it will just look, and it will just make a horrific noise of just going dee, and you don't want that. It's a really high pitched beep and it's really annoying. So 50 to 255 is what you really should be setting it to. Anyway, so just going to mess around with it, show off a little bit of the things show going around from 255 to 0, just because it's really fun. So the code is all there. You can pause it at separate intervals to have a look at where it is. You can just set it to different intervals and it will just go fine. So yeah, 1900 RPM. Can reach that. It looks like a very high speed as you can't really see it moving, but it is actually moving when you actually use a DC motor. It does actually move at 255 at the right speed. That is what it's set to when it's high. So if you need to look at the code at any point, just pause the video when you need it. You can actually pause it here. It does actually show the full code here. So if you need to access the full code, just set it to that and it looks fine. So if the certain things will be put into the description. I'm sorry about the audio. My recording software didn't pick up my mic, so I'm having to record this post recording, which is not ideal, but you make do with what you got. So there is nothing else really left to do. So just remember, there is actually a mistake that I made. I found this out afterwards. Do not change the 2 kilo ohm resistor. Keep it at 220. I just had a wire wrong that was messing with it. If you feel your transistor starting to heat up, take it out, maybe switch it around, move the pins from other way. There are different transistors that you can get. If it's still not working, the best place to look is on the forums for Arduino, because they have pretty much got everything there. So if there are any other issues, drop them in the comments and I will try and get round to them in one of the future episodes. I've recorded most of these in about the space of 24 hours, so it won't be done in the next episode, but they could be done in a bit later. This is the thing that we'll be using next time. It's an L293D, so make sure you find that because it's very useful. Always make sure you actually check which one it is. If you use the wrong one, it can actually start to heat up, which is not ideal. You do not want things on your breadboard, any components, your Uno, anything, you do not want them to heat up. If they heat up, it's actually very bad and can actually cause damage. It's also why you do not connect the motor directly to the actual battery. If you do that, you have a risk of burning out the motor. So don't do that. Anyway, that's all I've got for now. So thank you so much for watching. Goodbye. At 2:55.